So I should start at state and then go from there. I want to make sure I cover everything. I want to make sure I cover the important things in detail. So I'm going to kind of skip around. I'm basically going to go straight to do, but we need to define some things first. So let's go ahead and define both of our parameters. This problem says a state policeman has a theory that people who drive red cars are more likely to drive too fast. On his day off, he borrows one of the department's radar guns, parks his car in a rest area, and measures the proportion of red cars and non-red cars that are driving too fast. It says that he decided ahead of time that to define driving too fast as exceeding the speed limit by more than 5 miles per hour, which means that's kind of one of those things we can say driving too fast is as defined by the problem. To produce a random sample, he rolls a die and only includes a car in the sample. If he rolls a 5 or a 6, that's just so that he can have randomization in there. He finds that 18 of the 28 red cars are driving too fast, and 75 of the 205 other cars are driving too fast. Is this convincing evidence that the people who drive red cars are more likely to drive too fast as the policeman has defined it? So we need to define our two parameters. So what's my parameter? Is it going to be mu or p? Mu or p? P because those proportions. This is one of those where I think it is very obvious that choosing 1 and 2 would not be ideal here. What should I use that would make it helpful for me to know which one's which? So I'm going to do this one with, and I'm not really, time-wise, I'm not going to take the time to do this one. I'm going to do this one with red and this one with non-red for right now. That is not anything official. I should have definitely written out a whole lot more than that. But for the sake of, I'm going straight to do, but I at least have to know which one's which. So I'm going to use those as my notations. So I'm going to skip straight to do to make sure that we have enough time. So with do, I start with one of my p hats. Which one does the problem give us first? Red? Yeah. I usually stick to whichever order the problem gives it so that I don't mess myself up when I'm writing it down. So I'm going to do p hat r, which is 18 over 28, which is going to give me a number. Let me come back to. I usually choose to write, so when I do p hat r, I go straight to n from there so that, well, I just wrote it, so why would I skip space bar write it again? That's why I choose to not do my hats together and then go back to n. My p hat n is what over what? With an n of 205. While we're here, so I don't forget to come back to it, what is 18 divided by 28 rounded to 4 decimals? Yeah. And then this one. 3659. This ends up being one of those where it does a lot of this for me when I use the test button in the calculator. It does my p hat 1, p hat 2, and my p hat c for me. So I just need you to see where these are coming from, but our calculator is actually going to do it all for us. So then I also need my p hat c. What numbers am I adding in my numerator? So 18 plus 75. My denominator is going to be 28 plus 205, which gives me 93 over 233, which gives me what, round to 4 decimals? 23.1. What have I not written yet? Alpha, which is what? And then the other thing, which I didn't talk about, which I should have talked about when I did this, one tail or two tail. Is this convincing evidence that people who drive red cars are more likely to drive too fast? So if our null, and you don't need to write this, if our null hypothesis were this, which is what I would do because I just keep the order, then my alternative hypothesis would be that PR minus PN what? Everybody's with me with that, right? This is the exact same thing as writing where somebody else might have said, well, I want to do it this way. Their alternative hypothesis would then be what instead? And so these are saying the exact same thing. So you're going to have problems where like you and the person beside of you are doing the exact same thing, but it looks different just because they chose which one to go first. And that's fine. So definitely it's a one tail though. So test statistic. So I'm going to plug it in generically first. So based off of, let's just go with the way I have it written. So I'm going to do P hat R first. So P hat R minus P hat N. And I'm writing minus what up here? 0, my claimed value. Down here, making sure that we're on the same page. This is P hat what? Times. And this one is over what N? In R, whereas this one, which is also P hat C, 1 minus P hat C, is now going to be over in capital N. That's a lot of fractions and decimals to be plugging in your calculator. Now I want you to write it down. Some people are going to choose to leave the fractions, and I don't care either way. If you want to do it that way, that's fine. Especially because our calculator is going to do it all for us. It might be better to end up. Some people might prefer to leave the fractions, and I don't care. I'm just going to write it as the decimal form because I usually do it that way. So 0.6429 minus 0.3659 minus 0. And this is over 0.3991. And don't type any of this in yet because you're going to be wasting your time. 0.6009 over what? 28. This one is also going to be 0.3991 times 0.6009, but this one's going to be divided by 205. You are more than welcome to type in all this, but this is one where I would probably never ever type this in my calculator for any reason. Because the test button in our calculator does all of this for us. So go to stat tests. And then so we're going to look at our options here. So just switching everything. All right, so we're going to stat tests. We've got different options here. Is it 1 or 2? It's 2. It says sample or proportion. Are we sample or proportion? Sample just means it's not proportion. Are we doing proportion or not? Yes. We're doing a test or an interval. So which number is it? So this is 6. So 2 proportion Z test. So go to 6. And the input of it looks a little bit different than we're used to. And this is why I wrote this part the way that I did. So what is our X1? 18. What is our N1? 28. What is our X2? 75. Our N2? 205. And the way that I chose to write this was this one. So we choose to write it as greater than. So choose my greater than option. And then calculate. So it does our P hat 1 value for us, our P hat 2 value for us, There is a third p hat. So what is that p hat value? P hat C. You just have to know that that's p hat C because it doesn't give that notation. It gives you your n's below, but you type those in. And then it also gives you your test statistic value and your p-value. So I would never type any of this in my calculator other than using a test because there's no reason to. Even when I was explaining it, I went ahead and had you guys type in these numbers so we could figure out what they were. If I were actually doing this as a problem, I would have just typed it in my calculator and then gone back and written them in, or just left it as a fraction. You still have, yes, so you still have to write this part, but then you don't actually type any of it in. All right, so our test statistic value ends up being what? Test statistic value. And just because I usually write Z's as 2, but leaving it, a lot of you are getting in the habit of writing all of them as 30, and that's absolutely fine. So then I'm drawing my curve, drawing at 2.81. Which way do I choose to shade? The right Y, because greater than, and I know that I get my p-value, or that area of, what it tells me here, of 0.0025. Versus my alpha of 0.05, and I put what symbol in between? Which means, going on to conclusion but not writing it right now, we reject the null hypothesis that PR minus PN equals 0 since the p-value is less than alpha. We do or do not? Do, and then to some extent have convincing evidence that the proportion of drivers driving red cars too fast is higher than the proportion of people driving non-red cars too fast. But you can do that with notation. So I want to go through and talk through our conditions without actually writing them out. Since we skipped over that part and you're going to have to do one as homework. So going back through, I'm just going to look at my generic one I wrote. Here, what would I do for random? Is this random selection or random assignment? What part of the problem was random? The cars that he chose. So if it's the ones that he chose, that means it's selection. So it's the dice part that is making it random. So both the red cars and non-red cars were randomly selected using dice, something like that. Normal. What is my number of successes for red cars? My answer for my number of, so like my NR P hat R would be what? 18, which means my number of failures for red cars would be 10. So it would end up getting 18, 10, 75, and 130. So P hat or NR P hat R, NR 1 minus P hat R, and so forth, all those are greater than or equal to 10. So if I did this little box chart thing, I would say there are at least 10 what's relating to both populations. Let me write this one out. Okay, cars driving on, he didn't get very specific, did he? About where he was or when he was or anything like that. So just driving, cars driving, I guess, on this particular highway. So my side over here, what would go here? What are my two different populations? Red and not red. What would be in general here? Speeding or not speeding, or driving too fast, driving too fast. and I would do the box to check for that. Does that make sense without me writing all that out? Which means, so we can use normal approximation. And then independent 10% condition, I would have to make sure that, what would my capital N R have to be greater than? What number would my capital N R have to be greater than after I did 10% condition? So 10 times what? 28, so 280. So there are at least 280 red cars driving on this particular highway, and there are at least 2,050 non-red cars driving on this particular highway. So you should be fine checking conditions, even though I didn't write one out for you. We didn't technically write out conclusion, but it's the exact same thing we've ever done. Before I cut off the video, I don't think I said this in my last video. Your test next week is on Thursday, which is 2 days before spring break. It's on Thursday, so that if you miss Thursday, you take it on Friday. Like if Thursday is not your day, you take it Friday. What? Okay, I'm glad you said that. I was absolutely unaware of that. All right, but this might change this too. We were set to have the quiz next day-wise would be next Monday, but that would be take a quiz, turn around 2 days later, take a test. Also, I very highly doubt I could get those grades turned around to you before you take your test. So the quiz is on this Friday, which is kind of not fair because it's the same people that got messed up with the cumulative. But other than that, you'd never get to see your quiz grades before you took your test and have to take 2 tests in a week. I think you'd be happier having to figure it out. We're done with material on Wednesday, and I'm saying this more for the people online. We're done with material on Wednesday. So if you don't want to wait over the weekend, if you're a Friday not attending person and you want to take it Thursday, I can give you the review we're doing in Thursday, and you can have it done ahead and then just take your quiz on Thursday. So plan for a quiz this Thursday and then test next Friday, which I will look into about that. What you said, I absolutely was not thinking about that.